In this lecture, we are going to learn about Java memory model and how each part of the JVM memory contributes to run our programs. To help us with this adventure, I'm going to use the Visual VM. It's that tool for Java to monitor Java application. And on top of that, we are going to use a special plugin that will give us a more depth visualization of the memory. So the basic Visual VM will only show this two areas here, that it's the heap and the metadata. But the heap, it's a bit more complex than that. So then you're gonna need to have this Visual GC plugin. And to install that, you just need to go to Tools, Plugins. On install, you're gonna see this Visual VM. You just select it and it will be installed for you. After that, so you are gonna see this new tab with more information, and here you have few other information, not only the memory spaces that we have here, but also we have some graphs showing the history of our application in different areas, let's say. And we are going to come back to this, but for now we'll close this and focus only on the memory spaces, which you can see here. We have the meta space that we already discussed. We already discussed about that. So that is basically, it stores the class metadata for our programs, and this should not change if you are not loading new classes on demand while your application is running. So this will still keep the same. Here we can see two more areas, let's say like this. This is called old generation, and this add-in with SEO and SE1 that it's called a young generation. So you can divide it in the main two space, that old generation and young generation. So inside the young generation, we have three more spaces that it's the add-in, where the object is immediately stored. So the newly created object will be in add-in, and every time the garbage collection pass on the add-in will be moving for SEO or SE1 if the object is still being used, right? So why is divided in this three option here? It's because this space will be smaller and will be running garbage collection more often, and as the objects remain used, so it will be moved to these two survivors here. And if the garbage collection pass through a few times and the object is still being used, it will be moved to this old generation space. So why this is divided is to make the garbage collection more effective, as the frequency that garbage collection will be passed in different areas will be different, and however you'll be slower, right? So in the old generation will be running less, but it will take longer because it will contain more objects. And so before we explain a little bit more about this area, I would like to show a more intuitive graph that will help us to understand the flow of the memory and the data in the memory. So on this diagram here of the Java memory model, you can see how the memory works and how the data flow through the different spaces. So the new object created go to the add-in, and after they run the garbage collection, it would be moved to this survive space, one of those two, and after a certain threshold, it would be moved to old generation, and that would keep there while the program is running. So what's the difference of every stage here? It's basically the amount of time that the garbage collector will be running, and we can also choose a space, how much we want to reserve it to each space. So to the new generation and to the max new size, and you can see here as well that we are describing that there is a major garbage collection. It's a minor one that's smaller, and we can define the memory for the whole thing, the maximum and the minimum amount of memory for all space, right? Going back to Visual VM, we can also see some graph how things is behaving. So if you see on the old generation keep growing constantly, and this could indicate that something is wrong on the application. and this could lead to a memory leak. So the fact that this is growing in our application, this could tell us that this is a memory leak. It's happening, or you are just storing data and not releasing those. And then in our case here, this is happening intentionally because you keep our data as a sort of history of the all operation that you are executing, right? You're going to be looking at this later. So the adding still is being collected constantly, so and keep it low, but I think it's moving from here to the old and is not really releasing. And we can see the garbage collection is happening constantly, and it's very intensive. And the other thing that you can see here is the compile time of our application. So we spoke about this on the previous video about how much times the compile happened in the beginning, and you can see in the beginning it was more intense. So there is even something was even more intense in the beginning, and as the application goes running for longer, things becomes less and less, right? So because the process of a warm up already has happened. So the class loader is the same, so we don't load more classes, so it's very low. And here you can see the spaces on the adding, and every time that the garbage collection runs, you can see that release some space to the adding. And here the same, the survivor, and you see that things just go to the survivor 1, so the 1 is not really using. And the old generation here, you can see that even though the garbage collection, it is collecting time to time, so every space down here is because the garbage collection has happened, but even though it's cleaning, things remain increasing. And you need to understand why these things keep growing and growing, because soon we are going to run out of memory, right? And to investigate those kind of things, you need to go to the overview here, and we to the monitor, and we can get a heap dump, which will bring us everything that's being used at the moment. And for example, here, when we do this heap dump, we can see all the objects it's being used, and we can see that the most objects that we are using here, it is, I think if you look for the size, it's make more sense. So it has a hash map and a local date time, and then those two first hits from Java. So I don't believe that will be Java being holding things. So it's definitely something that our application you've been doing. So I suggest you focus on the first item from your application. In our case, we have here the cycle history, and that is the class that it's making our application consume more and more memory. And as I mentioned at the beginning, that happened intentionally because we want to keep all the history that is happening in our application, and everything it is stored on this class. So if you look at the class, what you have on this class is you have a hash map, as I saw there, and with a local date time, as you saw here, local date time and a hash map. So, and you can see those here, and then you can see that we are storing position, and we are storing field order, and we are also storing order DTO. So everything it's being registered as a way to keep the history in memory. We could change this to time store in disk or in the database and release this history. So keep a history like for hours or something like that. But we don't really need to do that now, as the application is just an example for now. So a little bit of recap. So we saw that our Java memory model is divided into spaces, so old generation and young generation, and inside the young generation we have more than one space for being used by the JVM in order to organize things better and be more effective. In a more generic way, you can just focus on the young generation and the old generation, and the young is where things stay when it's created, and as soon the garbage collection realize that object stay in use for longer, it's moved to another area. Okay. And so when you need to investigate that your old generation is not being released, never you execute the dump, and for that you can see some information that will help you to find what's the issue. You can also save this dump, so for example here, and this can be used for different tools. So for example here, it was pretty simple to find out the problem, but sometimes this what you have here is not enough, so you can export this and use other tools that would give you more hints about your issue. Okay, so I think that's all for now. I hope it was useful, and see you next lecture.